Awesome. So welcome. Okay. Yeah, awesome. So welcome to this week's Substrate Sync. We've got a full agenda, but maybe not as full as we think it is. And I'm just kind of kick it off. Right off the bat, I just added the Dalek PR got merged in. So thanks everyone who reviewed that. I think it's a lot better for all the reviews and took a long. Now we just have to propagate it out to DD Substrate Go and various other places. Cool. The first item that I had put on was actually about extension leaf versus extension table rel. So there's effectively two mechanisms to add leaf nodes to the system. Like extension leaf is like a full leaf and extension table is like a partial leaf in some ways. And the thing I was trying to think about is, are there cases where, or what are the cases where you need an extension leaf versus an extension table rel? And mostly thinking in the context of like what guidance should we be giving users, like use a table rel unless you're really an extension leaf. Like, do we want to have any language like that in the spec, or do we want to leave it fully open?
I remember I brought up something similar in the Slack before, and somebody gave an example of the difference. I'll find it. Yeah, in a general thread, a general channel, I said, is there a semantic difference between read rel with extension table and extension leaf rel? Aldrin was like, the difference may be subtle. Read rel with extension leaf are operators, whereas extension tables are not. Extension table would describe physical access path for a table. Whereas extension table, wait, what? Maybe I'll just share this.
Yeah, I see the thing.
Yeah.
I think maybe part of this is that I don't think there's any guidance around this. Something that we've been seeing internally is that in cases where there are like multiple ways of doing one thing, the example that comes to mind is like cross join versus an inner join with a equality condition on the key. Like those are technically equivalent and users can do both. But I think the guidance that we have internally has been use the most specific operator that you can. And I'm wondering if it's worth making something similar to the core spec to be like, hey, in cases where there are multiple ways to encode something, prefer the more specific one. So if you have cross join, inner join on true, use cross rel. If you have a thing that basically fits within a table extension leaf, or sorry, an extension table rel, extension table, use that, and then use the leaf if the power of the name scan's not sufficient. Open queue, Weston.
Yeah, I more or less agree with that, which is extension table is saying, I know this is a read, but it's maybe some format you don't recognize. So it's like, it's not Parquet, it's some other type of file. And extension leaf, the source could be anything, it might not be a read. Now, I don't know, if the consumer doesn't know about the extension, or whatever's looking at it doesn't know about it, then I don't know that that's much helpful to know that it is a read versus some other kind of source, but it could like it could be a different plugin points too, for like Data Fusion has table provider.
We have the cache logic that we added at some point where you could have saved data from some other location, like a hash table or something like that. So that would probably be more likely when you would use a leaf.
That makes sense. And I guess I don't think we need to describe or define all of this. I think the main take I wanted to get was like, would it make sense to have language suggesting like we have some preferences or we have some recommendations of what you should use when you can do multiple encodings? And this is an example of that, along with like cross joins and a couple other things. But yeah, can make it happen.
I actually think that that's probably a good page. Like a page that's like, hey, here's 5 things that are examples of things you can encode in multiple ways. Because the in clause, right, or the whatever it's called, the or list, I guess we call it, was another example, right? You could write that out as a collection of booleans. I mean, it's the same example as a variadic. What is the variadic function that you could also do as a bunch of ands or ors? I think there's several of them, right? Where you could have like 2 arguments, like add. Maybe it's not add. Maybe it doesn't have variadic, but I thought we had a variadic.
Is it like and if you have deeply nested and versus like having a flat and?
Yeah. Yeah.
Or an
Okay.
end list versus a bunch of bullet.
Yeah, I think that's sufficient for us to go on and go forth. Cool. Next item. Oh, yeah, I was thinking it might be time to propose new committers and PMCs again. Maybe I'll start with the bigger one. I was thinking that Young Troll might be good for PMC at this point. He's been reviewing a ton of the work and really very thoughtful and careful about it. And it would be useful to have more people who can do spec approvals for capacity. But I'd float it in the room first. Also, surprise, maybe I should talk to you first, Young Troll, but yeah, if it seems reasonable, I'll start a vote upstream or the email list.
Yeah, I mean, I'd start a discussion on that. Anybody else that you think? Like, I think people should always be watching for that. Start discussions on them. Yeah, and just stick to SMC, not PMC. Come on.
Why am I thinking PMC? Oh, because
Apache's all PMC. I mean, I think we all know what you mean, but
yeah,
we're not a substrate project. We are the substrate project or whatever.
the Substrate Project Management Committee, the SPMC. I need more sleep. And yeah, I was also going to float Ben Bellick here as a committer, but I'll make that in the email list as well. He put up with us on the canonical URL stuff, and he's going through and making all the changes in the various libraries. So I think that could be helpful. Cool. I'll propose those later on then.
Yeah, those are definitely worth an email.
Yeah, awesome. Other thing, Substrate Java release problem. That's a lot of stuff going on this week. Semantic release is weird with GitHub permissions. So I think that going back, the main branch on Substrate Java didn't used to have branch protections on it a couple months ago. That seemed kind of like a bad thing, so I turned it on. The issue that happens is the way that we do the Java release, the semantic release bot wants to make a commit directly into main and release that. But there's no way to give that bot permissions specifically. So the making a commit into main as part of the release process is kind of causing us problems. I'm not sure there's other patterns for Java releases that would be better.
That sounds like it's a problem that Ben can solve. He likes these really gnarly, fun problems.
I mean, someone's got to do them. So
what I've been doing in the interim is I turn off the branch protection and run the release workflow temporarily, which works well enough for now. I think this is mostly.
So what changed?
I turned down branch protections.
No. But before was it working?
It was working because branch protections were turned off. Main was never protected.
And then you turned them on, and it broke it.
I turned them on because I think someone accidentally merged something into main without review, and I was like, that seems bad.
You can turn on branch protection for specific people, I believe.
You can, but the bot isn't an entity that you can give exclusions to. It's not part of our organization. You can't make it part of our organization. You can't invite it. You can invite it, but it won't accept it. It's a bot. And the other curse thing is if you look at the semantic release action, there's somewhere in their docs where they say don't making a commit as part of the release is an anti-pattern as far as our GitHub action is concerned. This is more like if anyone has a good idea about how to deal with this, I'd appreciate insight. If not, I can make an issue for it, and I can follow up with the IBM folks actually who are the most invested in this, and maybe they can look at it. So
take away the commit bits of people who merge, who push direct.
Yeah,
I'm joking. I'm joking about that. I mean, I think that my main comment would be people make mistakes every once in a while, right? As long as we say, hey, don't do that. If it's happening once every 6 months or once a year, do we need automation to protect us? Or we're not that big community. Do we just fix it? That's the one thing I say. It's I mean, I agree with you. I prefer branch protection. But if it's okay, well, we're going to spend days working on this, or once every 6 months or a year, someone makes a mistake accidentally, and we say, hey, don't do that. And they're like, oh shit, I'm so sorry. Is that okay? I'm asking the question. I'm not arguing for it. I'm just putting it out there.
Can we put more branch protections in the pre-commit, or and usually when I want to make sure that I don't do something wrong, I put a check on my local GitHub workflow. We can put something in the project work somewhere at the project level to help people not do the wrong thing with the branches.
Yeah. Oh, I think this is good food for thought. It sounds like basically no one has a clear idea about how to do Java releases in a way that we're not doing that, or opinions on it in a way that's not how we do them now. So I'll follow up with the IBM folks. Actually seem to know a lot about Gradle and GitHub Actions for curse reasons, so I can poke them, see if they have any suggestions on it. Yeah, I don't think we just spent too much time on that. So many things on here. Final item that I have on here for this week is the named rels for the same table with different schemas. So this has come up before. The idea is basically you have a named rel, but they're like you're doing a join between two tables, and you prune them and they have different schemas on them. And then you merge, you try to process them in your system. And you can run into issues if those schemas don't agree, if your consumer makes assumptions about them having to agree.
Let me pause you for a second there. I just want to clarify something. Because there's I don't remember what it's called. Like there's the base schema.
Yes.
Which is the schema of the table before any projections.
Yeah.
Of
this is the base schemas differing.
How can the named table have the same table have two different base schemas?
Because from our perspective, we prune the subtree separately and we prune the base schemas directly. So there's two
base schemas shouldn't be pruned.
So there's actually there's an argument for it and an argument against it. The argument against it is like the base schema should be the same. Like the name table is constant, right? Like it should be the same. The caveat is, and this actually comes up in the protobuf encoding sometimes, if your table happens to be like hundreds or thousands of columns wide for godforsaken reasons, then that means that you have to inject that into the plan, even if you only care about like 7 columns. So it kind of goes against column. It works against column pruning, because I think that the traditional answer would be the base schema should agree, use a mass project, and that mass project kind of extracts the fields that you care about. The caveat is at that point, you still have to give the 10,000, like the 1,000 columns in the schema, which blows it up a lot.
Yeah, but I think that's the semantics. I think what you're saying is, I didn't like the semantics. I'm not you per se, but like one didn't like the semantics because it made the plans big. So we just did something else. And so I'd say like, let's figure out the right way to solve the problem, which is large schemas, right? As opposed to, because I feel like you're using it in the wrong way. And then you're like, hey, this is weird. And I'm like, yeah, totally weird. Because the rule is that base schema should not be mutating, right? It should be.
Okay, the other caveat, there's actually nothing in the spec restricting it, technically speaking. And that's the other thing, it's technically UBI. And this is also part of like, we should clarify what their actual restrictions are. Should they agree? And if so, okay, we should include it in the spec. And if we were forcing them to agree, what other do we want to solve a separate problem of large schemas? Because I don't disagree. This is definitely like a encoding problem that leaks into the semantic space.
So there's one related area which would be like schema evolution, right? Where the table was one way and then a column got added.
But those plans should exist in a point in time. So if the plan is referring to the same table twice, at that point in time, the schema should be the same for both those tables.
Yeah. I mean, slightly more like, I don't know, inviting approach would be taking a schema union. So if you have a name table, you just union them and then try to resolve the conflicts. So if, you're saying column A and you have different type, okay, this is, no, it's a nonsense. However, as long as there's no conflict, then maybe define, okay, this plan, even though you're referencing, say, twice, slightly different set of columns, they don't agree. As long as they agree, or they can be unified,
then we can just allow it. I mean, that could be one semantic that we could use.
And that's consistent with the intention of the spec, right? Because
Yeah.
it's possible that you define a table
Mhm.
as like columns A, B, and C, and create the plan, and you add column D to the table, but the plan doesn't know about it. So
Right.
the plan only has A, B, C.
Right.
The expectation I would have with the spec is that column D just is automatically excluded, right?
Mhm.
If the
Yeah.
underlying table has columns that are not
Exactly.
defined in the original schema
Right.
in the
Yeah.
read route,
Yeah.
we would exclude those.
Exactly. Yeah.
And
I
so,
mean,
yeah, so if Victor has a
Yeah.
giant schema and then it's got two projections of that in two
Right.
different tables, I
Yeah.
agree with you. Yeah, you union the ones that do exist,
exactly.
and that would be consistent with the spec.
Yeah.
Or
So that
intention of the spec is not written down.
yeah. Yeah. Or the other extreme is like, okay, we have to include all this base schema as is, probably once. Yes, it's yet another alias or anchor.
The other way that we sort of have done is that you can build the plan, and you look at the base schemas for all these tables, and you create the union in the producer, and then you basically be like, okay, give me the widest shape of the schema, and only send those fields, and that works fine. Like that's one way to approach this is for that. But I think to Jack's point, you made a good point about like there's a separate problem, which is like the large schema problem, or even if we don't have that, like, do we actually want to be like, send me the large schema? And that only becomes a problem if in conjunction with this, like these things don't agree. Because to your point, the way it works now is you have the schema, and if your source doesn't agree with your schema, oh,
Don't worry. Done.
That's better. Great timing.
I'm muted. Cool.
Yeah.
So I just want to take a photo of my room to show us on the fire trap. It's only a problem if the base schema, like if it's wide. Sorry, I forgot my train of thought.
I could throw out a wild alternative explanation or approach, which is that projection itself is somewhat format specific, and all you care about is the output schema of the read, and then projection is like part of the format almost.
I'm not sure I understand which projection, like the mask on the read rel, or
Sort of like the projection and I mean, what do you need the base schema for? I think you need the base schema plus the projection to kind of figure out what data they're interested in. It's a read rel. You're saying, here is the data from the file that I'm interested in. And that could be file specific. Now, in most cases, most files can support mapping from like a list of names and types to some part of the file. And then there's like the output schema of what am I getting out of this read. So it's like, I want to read something from the file. What am I reading from the file? And then my output schema, what am I getting out of this relation for the planner and the other Substrate nodes to kind of know how to process this. But like anything in between is really just details. So like a base schema, I guess the broader question is like, why do we even need a base schema?
so I guess the names are attached to the base.
Well,
it's also useful actually for reasons, because some of the query sources, some of the read rels, for example, we have a read rel for one of our internal systems, which is like basically Elasticsearch, and it's like we use the names and the schema to like get me these columns out of the system and make sure they're the right type.
Yeah.
So like the schema is actually used as part of querying the underlying system.
Yeah, that's what I'm saying. Like the base schema plus the projection are sort of almost like a format specific way of specifying what data you're interested in. And then there's the output schema, which is like the Substrate way of telling you this is what the data sheet actually is that's going to be spit out of this. Like I could invent a file format that doesn't have names in it at all. And I would just specify a projection as like, it just has columns. And so I say, oh, I want columns 3, 5, and 7. And it's
Those are the names.
You could make them names. Like you can fit it in there, but I'm just saying.
That is not human names.
There's a piece of
Yeah.
Forget names.
So let me respond to Weston for a second. So, yeah. So the idea behind these fields in ReadRel when I was working on it was, what are the kinds of things that you need to know for most formats? And so rather than having to create, because if you think about the structure of the actual thing, right? Those fields, the base schema and the mask projection, whatever it's called, and the filter, they exist at the highest level of the proto message, right? They don't exist inside of the individual table definitions, right? So like if you have like a CSV table, inside CSV table, you have like delimiter, right? And that's a CSV specific property. And so rather than copying and having the same thing defined in every sub table type, we were like, hey, these are the things that seem to be relatively common in their use. And so going back actually to the comment before about the extension leaf, right? If you have something that looks very, very different, right, that these fields just don't make sense for, then that would be what you use extension leaf. And so that's kind of the way that I was thinking about this is like, if most of these fields make sense in the context of the thing that you're sourcing data from, then you use the read rel. And if they don't, then use extension rel and extension leaf, right? And so like I could see a pattern where if you want to get very custom for how you're going to have to draw certain fields from a system, right? And you want to make that say as compact as possible, then that would be like, okay, that's just a different rel. That's not read rel with its standardized set of fields. So I agree with you, Weston, that like in some ways it's like I only care about the things that I want to read out of the system, and I only care about them in the way that that system needs them, right? And so if the system is ordinal based, I don't really need strings for my field names. And so yeah, I think that's fair. Like I've argued before that CSVs are really ordinal based; they're not name based, except that they have headers sometimes. But I would say that like at least the thinking was initially was these are the properties that we need most of the time when reading most of these common formats. Yeah.
I'd argue that all file formats are ordinal based. The
What's that?
I'd argue that all file formats are ordinal based, and the schema is just a way of translating from names to ordinals. But
I don't know that JSON is ordinal based. I don't know what to say, man.
like, I guess, does a Parquet consumer need the base schema? I think it does because the projection isn't going to specify names by itself.
Yeah, well, I think that the experience that I've had in the past is that systems will insert columns. And so column chunks in Parquet are not consistent for the same column position. Like the same column doesn't show up in the same order in all Parquet files. And so that's why names are important. But yeah, there's a whole like, I mean, that's a huge part of the iceberg spec is like just the rule. I remember spending time with Ryan talking about all the rules around this shit.
Who uses field IDs anyway at that point?
Yeah. It's just like, you're like, okay, we got an extra level of abstraction here.
I guess going back to the original question, so the original issue, I guess there's still two things. It's one, there's a read rel problem of the base schema is really wide, and even if you have a single one of them, do we want to make the case, or the language? It sounds like we're in agreement that your base schema can be a subset of the actual real table, and that's fine. Which is
I think what we should say is that we should, if we don't formalize it, we should just specify if the expectation is if you read a table and the base schema has things that are, sorry, the table has things that are not listed in the base schema, they're ignored. Right? Because if you say that, then you're fine. But the base schema of the same table should be consistent throughout a plan. It seems like that solves your problem. But there's a separate question I have, which is that how big are schemas really? And I don't mean like I've seen 10,000 column tables. I'm just like in proto format, I'm guessing that these things are like
compacted
3 bytes plus every name.
The other caveat is that once you start trying to look at these plans, they're hard enough to read already, and then you add like 10,000 lines of JSON formatted protobuf, and it's like this is unreadable now. So part of this is also part of the reason we do the column pruning is to make the plans readable by people who are like, is this correct?
So what you're really saying is we need a better text format, or a text format that people use.
I think
Like,
even with a better test
I'm
format,
not
rendering
dissing
that
David's
output would
text
be-
format. I'm simply saying that like you're not using it, right? Not to say that it can be solved, but it's like plan representation is a problem. That's what you're saying. And so sure, we can try to fix that by changing plan shape, but we could also try to build tools for plan representation, which maybe is what we need to do.
So I'd also just say that, like, let's say you have 10,000 fields in your protocol. It's not that large, but then I've just seen system after system after system generally assume that the schemas are small, and they do things like copy them all over the places and stuff like that. And so it's just like,
log.
sure, you could argue
Log
they should
point
do
to string,
that,
please, and send to this debug log.
but also like having information in a plan that is not used, even if like file size is not that big of a deal, just leads to extra processing.
Yeah, okay. So I guess just to summarize the takeaways. Oh, go ahead, Youngchul. You're muted.
Okay, I'm muted. Yeah, unmuted. So the rel command doesn't have any like output schema. It is relying on the whatever the base type that is rel is defining, and then the rel command simply just remapping, rewiring those things, whatever this like native things into like rewire things. So without like base schema, some sort of mapping, like we don't have a ground to run this like type derivation. And now that I'm looking at the extension leaf like doesn't, it's completely missing the type. So, well, I mean, maybe that's by definition, because like it's extension. I mean, if you don't understand that, you cannot use it.
There's a thing there where, yeah, actually, that's probably another requirement to add, which is, this is a separate thing, but
Yeah.
like extension leafs, you have to be able to derive a schema from them. And that can either be, given the content of them, have some way to give me a schema, or the anti-pattern that I've seen is, you put a name struct inside of your extension leaf. That's basically a read rel with less stuff in it, so maybe it should be a read rel.
So I don't know, like perhaps like we actually need to add that whatever base schema equivalent or something like that, so that we can just ground it.
In rel common?
This is true
Sorry?
for all extensions, by the way, not just extensions.
Yeah, I guess all extensions are all nodes actually need to be able to derive outputs based on their inputs. Extension leafs are special because they have no inputs, but they still need
Right.
to be able to derive their output.
Yeah.
The derivation rule for re-rels is take the base schema, apply the mass
Right,
projection,
exactly.
do filter,
Right,
and then apply remaps.
right.
And that's how you get your
Yeah.
final.
So the reason that, so just as a concrete why, because I think what Youngchul is saying is that like, hey, should there be one more field which is like schema
Exactly.
to
Yeah.
extension leaf?
Mhm.
And the reason that there isn't currently, I'm not saying that we shouldn't, I'm saying I'm giving a reasoning.
Yeah.
Is the thinking was that any existing leaf node should be able to be put in extension leaf if you wanted to, right? So like if you wanted to take read rel and modify it slightly and stick it in extension leaf, you could.
Mhm.
And so read rel is a good example of like, hey, I'm defining schema in a way that's not materializing the schema directly.
Mhm.
It's a base state with a set of rules. So if you added the schema to the top level of extension leaf, but then you embedded, say, read rel,
Right.
or your own, my read rel, you would be duplicative.
Mhm.
So that's why it's not there. But I think at a minimum, it should probably clearly state that yes, this extension leaf needs some way to express how you're going to find schema, which is true of all of the extension rels, right? Is that all of them
Yes.
have to figure out how to determine schema.
Right. Yeah. I mean,
But yeah, we don't store it.
yeah. So at least I don't know. Like if we expose that information, like essentially we expose those like type, then we can at least like validate. Like modulo, what's in there in the detail, we don't care, but at least we can check the validity of the plan in terms of the types. So
Yeah, I mean, I think this is an interesting question, which is like, what can tools that don't know about extensions do with those plans? That's really what you're getting at.
Yes.
You're saying, hey, it would be nice to be able to validate a plan schemas,
Right.
even if I don't know the extension leaf
Right.
types.
but if it is extension, do we really care? Like, I don't know. Like, that's a
Yeah, I don't have, I actually don't have any, I have very little opinion on that. Like I like the pattern of saying that, like, for things that are, not semantic changing, what do we call them, hints or whatever it is,
Mhm.
that you can ignore those and the plan is still correct.
Right.
Like, that's the pattern. But this pattern of, like, I have an extension leaf, I'm working in a system that doesn't have the definition for the extension leaf. What can I do? It's an interesting question. Yeah, I mean, I think it's a reasonable argument to say, let's put the schema in there, because then I can work with the rest of the plan, even if I ignore that node.
Exactly. Yeah.
Whereas if I don't have the schema, then I can't work with the rest of the plan.
Mhm.
I can't work with that plan at all.
Right.
Yeah.
Yeah, and I wouldn't worry that much about the duplication thing, because just don't do that then. If you don't want your schema to be duplicated, don't put it inside of an extension leaf. Because I could put, a extension leaf inside of an extension leaf, and I could nest it 20 times, but I'm not going to complain if I have a lot of protobuf at the end of the day.
Yeah, it was more that, like, you have to because of the way you need to represent it for the primary system, for the whatever the system you're sourcing from.
Conceptually, including the name scan, or including some kind of schema in the leaf makes sense in the context of validate plans where you don't know how to process the leaf, so you can't implement the derivation logic for the output type, but you still want to be like, is the rest of the plan valid relative to this leaf? It's also useful for actually making sure the systems agree, to be like, I sent you a leaf, here's what it should output. If you don't agree with me, you're probably not using the leaf correctly.
Yeah.
I mean, that argument, whatever that argument is, it probably applies to all of the extension rails.
Yeah.
The multi-rail, the leaf rail, the single rail.
Yes.
I guess the caveat there is, if I'm implementing a consumer of a plan, when I implement the aggregate rel, I have my derived row type method for it, and I can look at the spec and do it. It's more like if I get a node that's like a protobuf any, it's like, I don't know what this could be. This is custom to your system. Like, there's no pre-assumption that I can implement logic to derive row types for arbitrary relations.
Yeah, that's why he's saying encode it. If we encode it, then if you're a system that doesn't understand it,
But I'm
you
saying we
can
don't really need that for
you can
every
work
role.
all around that node and just ignore that node.
As another point in that favor is, do we have an extension expression? I think we do. So we do have the dynamic parameter, and we require listing the type parameter. Like we go to a lot of work to make sure it's easy to tell from all the expressions what the output type is. It seems like the relation, the output schema is more or less the equivalent concept.
Mm-hmm.
Yeah, it's funny though, because this conversation started with a problem where our schemas were taking up too much space. Now we're saying, let's add more schemas that might not necessarily be necessary. That maybe duplicative.
I think there's a lot of room for thought on this, both so we can percolate on and look at it offline. I do want to get to other items. I think Ben's got some stuff, and then Youngsho, you've got some stuff as well. And there's some actual stuff that I can try and make PRs for this week to at least clarify stuff that we've broadly agreed on. Ben.
Yeah, I had one little thing that I wanted to raise, although I also didn't know that the Slack channel existed, so maybe that would be the more appropriate channel for it anyways. But I'm now a member of the Slack channel. But anyways, internally to Datadog, we've been having this issue where we have been using a project set relation internally, which is meant to model something which takes in individual rows or sets of rows of a relation and produces more potentially or less. So the kind of common example for us is the unnest relation, where you might want to take some array and explode it.
Yep.
And I was trying to figure out what kind of the substrate TM way of doing this kind of thing would be. And I stumbled on an issue where it seemed like there was a bit of a discussion, but not consensus exactly. I linked it in the notes, but I think it was basically you, Jacques, just saying maybe this should just be a table function and table relation. But this was in 2024. Maybe things have changed. So this is my checking up to see if there's any hovering consensus on what the right way to solve this problem is, or if we should just continue doing it in our kind of custom way.
Didn't we build something that solves this problem? Didn't we go through like a long set of discussions like a
I
year
hope so.
ago?
Did we?
That's what I'm
ever-
hoping to
And then
find out now.
expand rel.
Yeah, expand rel.
Expand.
Yeah, that's what the link
Ah.
is in the doc. I thought you were saying it was a discussion, but it looks
Is
like
expand a nest? I guess.
more. No, not quite.
And I guess the broader discussion, as I remember, and I think it mostly just stalled out because no one needed it badly enough, and we had our workaround internally. But it's like, do we need a general way to represent set returning functions? So like a nest, JSON each, and anything that returns multiple rows per row, basically. And I think I think from what I recall of discussion, it was like people were probably like something like this could be useful, but we never got off of it.
Yeah. Expand rel is a very it's a concrete, more or less, set returning function, so it can't be used for generic set returning functions. And I believe, if I remember correctly, unnest is more general than expand rel, but expand rel is all that Spark supports. So it existed in sort of the little middle ground. The motivation for expand rel was to try and get more parity with Spark.
There's a world where we can replace the expand rel with a more generic something or other. But I don't think it
Yeah,
exists.
so
We were talking about it, but we never actually got around to. I guess the people who were interested never got around to actually doing it because it wasn't needed badly enough.
I believe there's an issue that so SQL Server and some other systems actually support something called like cross apply. So it's for each row you just run this query and slap whatever thing to the schema. You can generate like multiple things. So this is like probably a little more generic version of the unnest or expand, that you are actually specifying full relational expression there.
Is that like the correlated subquery thing?
Yeah. Yes.
yeah, I mean, I think yes, it makes sense to solve for it. I do think that a lot of the thinking that went into expand is the same thing that should be applied to this. The reason expand took a little time was because it was like, how do we get to the primitive version of this as opposed to like snapping it to a particular system's representation.
Mhm.
And so I think I think it's a lot of the same thinking, which is like, hey, but I think, yeah, cross apply, whether you call it, I don't like, I think I would go with something that is more general. So like cross apply.
Yeah.
I think it's easy enough to add like a cross apply relation and a nest relation, a like JSON each relation, like one by one, and that would be a way to solve this problem. But it ends up creating a lot of relations from one-offs.
Right. Right.
The issue from what I recall as well was that like every system has a slightly different way of working with this. So they're sort of the same thing, they're not, and trying to basically get the taxonomy of like what would be solved by this, what could go in this, and how to be unified was like the trick, and that's the kind of like the bulk of the work.
I think it's okay if relations are not handled by all systems, as long as, kind of what Jacques was saying, the definition for that relation isn't system specific. So it's like expand has a pretty generic definition. It could be used. And yeah, I don't remember exactly what the initial proposal was for expand, but I seem to remember it had.
It was very implication focused as opposed to like descriptive.
Yeah.
And if,
So,
I
don't remember this
generic
exactly.
unnestral is really easy to write, actually. Like we've got it. It would be really easy to upstream. But it's more, do we want to have an explosion of all of these things are the same category. I think that maybe we need like any kind of function definition, like table value function or some such in the YAML files to be able to add these generically. Because you end up with like range functions, generator functions, a nest function, which are all like thing that takes some input and generate rows of data.
Would that be more informative than an extension row?
I mean by extension row.
I think it's common enough that we should do it. Like to sort of, I think Weston's saying, hey, should we put it in the main or should people just make their own? I think is what you're asking.
Well, not quite. I guess you're saying, like, there's this pattern. If the pattern gets to be to the point where it's so generic that it's like, I have this thing that takes input and spits out rows of a certain schema, that's just an extension. Like, that's the pattern. Like, if it's more constrained in some way.
Well, I think that is, I have a function, and this is where like I'm waving my hands, but I have a function that takes in a row and creates multiple rows.
Okay. Like I have a
and
function
we need a
that
system
would apply on
around
each
how
row.
we can work with that.
Yeah.
Okay.
I guess in the same way that we have in the YAML extensions, we have scalar functions, aggregate functions, and window functions. I feel like having a way to define these as YAML
If
and
you go look at the PowerPoint, we have table functions too. I mean, it was in the PowerPoint 4 years ago. I don't know what you're talking about.
I guess the TLDR is yes, there's appetite for this. We should make a proposal and look at it.
Yeah.
And I think to your point, it's really easy to add an extension on nest row, which is what we've done, which is why this hasn't come up a ton, because we can unblock ourselves effectively, which is actually a nice property of the spec. But we're kind of like, we should solve this upstream. People keep asking us about it inside.
Yeah. So I just probably don't have as much experience across all of these different databases to understand why this is not the case. But why can we not model it as an extension which just takes in some function that's like a set returning function, and then the definition of the relation, we can call it expand or whatever it was called in that particular issue. Expand rel is fine for the sake of this discussion. And it just understands to apply that set returning function to each row of the relation to generate a project set. That's a good name for it, because basically it's just a projection to produce a new column based off of this set returning function. It's like, what are the cases that doesn't work as a model for?
Well, it's not producing a new column, it's adding new rows.
Well, sorry.
No,
It's adding one column, right?
Well, there are cases where it's adding more than one column.
I guess there's nothing
That could be two
stopping us from
projects
doing that, right? Actually, that seems like a reasonable idea. The caveat is we need to do the legwork to like, okay, what are the functions that we want to be able to implement using that feature, and will this thing actually be usable by those things?
Right. Yeah.
And that's where like cross apply, unnest, JSON-H, any godforsaken number of table functions. Like
I think if you go look at the table function discussion, I don't know that we came to a consensus, because I think one of us thought it was 3 types and one of us thought it was 4 types. I don't remember the exact numbers, but if you look at that discussion, we basically outlined that there are several different table function patterns, and this is one of them. So if you go look at that, there are like these different table function patterns. And this is just an example of one of the table function patterns. So I think it'd be good to review that. I think we've probably done 70% of the legwork in that discussion around table functions and the discussion around the expand row or whatever the one is that we already have in the spec. That I think, and I'm completely fine with saying let's introduce the table function subtypes one by one. Right? If there are let's say that there are 3 types of table functions. Let's say we introduce the type that solves this problem first. Because I mean, the way I think about table functions is basically it's a scalar set of inputs, like maybe multiple columns, but it's a scalar set of inputs that produces a multiple.
Yeah. No, I don't. So yeah, I guess my takeaway is everyone broadly wants something like this. The caveat is we don't know what shape it should take, because it turns out there's a lot of different things this thing can take, because SQL is a nightmare.
I'll save my griping for the PR. I'm not sure I probably want something like if it's just a name plus the statement that it takes input rows and produces output rows. It's too
But it's more
generic.
like, imagine it was a name that's like, cool, we have defined the unnest function as consume input and return these output rows. Or we've got
I can
range.
define filter as consume input rows, return output rows. I can define project as consume input rows, return output rows. Like,
Well, but unnest is, I mean, like, I would argue that unnest is that, like, I mean, what, Weston,
take your
I
function
feel
name,
like,
make it the type URL, and make it a single extension leaf row. And now you have it.
well, no, yeah,
Or not leaf row, a single extension. Your function name becomes the type URL, and you're good to go.
so you don't believe in table functions? Is that what you're saying?
Well, table functions, that what I'm used to seeing as table functions are things that have no source, and I would say that's just an extension leaf row.
I guess they're extension leaf rows, but they're extension leaf rows that are common enough that it's like people keep reinventing this. We should just give them one so they don't reinvent it.
Yeah, I mean, to me, if
You
you're
can
talking
have
about
standard
cross compatibility,
extensions. You can say like, this is what the unnest extension looks like.
I think one of the things that
Extension.
Weston's saying, which I think we don't do right now, is we don't embrace the idea that there are first-class third-party extensions, if you will. Like, we're like, oh, okay, we got to put it in the spec because we want multiple systems to use it. But it could be that Datadog creates their own repository. It's a public repository of Substrate extensions they think are useful, and everybody starts using them. All right. So I think Weston is fair that that's kind of saying is like, hey, there's nothing wrong with first-class third-party extensions.
Yes, that's a noble way of rephrasing what I was trying to say. Yeah, I guess I see it as like, if you give me a message that has the exact same structure as an extension row, but you've exploded the, you just said, okay, we don't need the any part, and we've changed the type URL. Like you're not providing any value. Like, it's just multiple messages that have the same concept. I'm just being cranky. I'll wait until there's a PR and then I'll be cranky on that.
Yeah, I need to think of that
I'll
more.
say one place of benefit is that the exact discussion that's happening on my end in the other channels and Datadog doesn't happen because there's just an agreed upon way of doing the thing, which I guess you can get from kind of a common public extension repository that's third party, as Jacques was saying. But still, it's nice when common problems are solved for you instead of figuring out how to solve them.
Well, and I think that that's probably my feeling about a first-class third-party thing, is we're not big enough right now that we can't solve it here. I feel like is the case. If 5 people want it solved, that's enough to solve it here.
And I guess
We shouldn't be like, oh, we're not going to solve it here. You go solve it someplace else.
in some ways, also the root of the problem is both actually internally and externally. People come at like, hey, so table functions are a thing in SQL. How do I model this in Substrate? Right now we go. So in some ways, this is we need an answer to that question, and not sure what the answer is, but that is a good question to be able to say like, here's how you do the thing that you're really used to being able to do.
Yeah, Weston's. Let's just write down Weston's response. Table functions are stupid.
You don't have extensions in MySQL. They're called table functions. That's my response. But
I mean, but come on, when you create a user-defined table function, like that's an extension.
I'm gonna put
That
that
is
on
an extension. That's what I'm saying.
And I want to make sure we get the Young-Shell stuff, and then we can spend another 30 minutes discussing the validity of table functions and why SQL was a mistake. Young-Shell.
Yes.
We can rename the extension message to table function, the extension leaf row. Then we don't have a problem. All right, I'll shut up.
Type aliases.
Yeah. So the first type alias PR is so incorporate all the feedback. So we just need approval or review. So please.
Oh, when you say done, you don't mean done. You mean like
done.
You're
means
done.
like incorporating. Yeah, I'm not.
It's incorporated feedback and requires PMC approval by 3 people.
Yes.
Okay.
Cool. Actually, I made a note on that. I'm realizing if a PMC makes a proposal, I'm assuming that requires 2 additional votes by PMC, because I assume that proposing the idea is an implicit vote of the idea by yourself.
But what do we require? 3?
We require free PMC. So we require free
Yeah.
PMC votes?
Yes. You can vote for your own thing. Yes.
Okay, cool.
Yes, for, as an SMC.
That's how I merged it.
approval
Dialects
type,
got
yes.
merged with free approvals, and you count that. So I think both David and I worked on it, and we implicitly, yeah, cool.
Yeah.
Then
So,
I guess you've also got the unity for type literals because
right. Yeah. So that is like hindsight that Jesus caught. So UDT literal is kind of mess right now because it kind of like embedding the type in the literal. It's basically inline the type definition, type message in the UDT literal message. So that creates like some mess to supporting the type alias in there. So in the PR, I propose like 3 options and like let me know like which one you like most. So please take a look. And the last thing is actually kind of related to the first party, third party, whatever, first class, third party extension thing. So what we found is okay. So it's basically boils down. Okay, we have systems that behaving slightly different from other places. So how are we going to incorporate this behavior? I mean, naturally, there are 2 things: either you add some field that signify that behavior, or we just slap some extension that okay, if you see the extension and understand it, do it in that way. There are 2 things. And the more specific context is like how we are handling empty grouping set in the grouping set, in the grouping.
Mm-hmm.
So I did some survey and it looks like a SQL Server and the Oracle are on one camp and the rest of the world is on the other side.
Of course.
So
what is the behavior actually in question?
So basically, SQL Server and Oracle, if you have grouping set with empty grouping set, it behaves like a normal group by. So if you do count star with grouping set with empty grouping set, it actually should produce 1 row, 1 empty table. However, SQL Server Oracle doesn't produce any row, so it's effectively just behave as a normal group by. So that's, yeah, this is like a very, very puzzling behavior. It's a very, very niche case, and but I even use some hilarious experience with LLM, like feeding Copilot and the ChatGPT, like which one is right, and then it gives like, yeah, it's interesting topic. But so the SQL standard is saying empty grouping set. If you have empty grouping set in the grouping set, then you must produce 1 row, at least 1 row. Even for the empty relation or empty table, you have to produce 1 row.
And empty grouping set is distinct from not set grouping set, right? Or like unset grouping set.
Unset grouping set. What do you mean?
Like if you have like group by but no group set.
Group by, no group set. Yes.
Yeah.
If you have like
So I would argue that if there's major systems that have a small variation in behavior, like I'm trying to get to the question. I think the question is, how should we handle these kinds of things? And I think if there are major systems, and I'm like, like whatever, if you're in the like top whatever 50 databases that exist, and you have something that is 99% the same but 1% different, if you will, which I think this is an example of that. I would argue that we have a field which defaults to the most common behavior. If you're the 5,000th largest database, then I would say no, let's not add a field. Just use an extension if you want to do this.
Okay.
But if you're in that, say, top 50, you're in that whatever the database, that database chart where it's like who's the leading database. If you're on that chart, I would say that we should add a field that clarifies with the most common being the default.
I see. So perhaps like for future, I guess like I don't know, if everyone agrees, then we probably, there's like some conflicts of interest because I happen to work for like one of the systems.
No, like to me, it's simple, right? It's like if you're in SQL Server, you're in Spark, you're in Snowflake, you're in Databricks, like you're on Oracle, you're on MySQL, like we like that is a reality that exists today that is very common. And so like I don't want to say like, because the other alternative, right, is saying like, hey, create these SQL Server grouping set relation, which is exactly the same in every way, with the exception of the fact that it has this behavior difference.
Yeah.
And it's just like, that seems heavy-handed. So that's kind of my perspective. It's
I mean,
just,
slightly,
just add-
yeah, slightly more like less intrusive way in that along that path would be just having this like empty message extension, this first class third party extension that the grouping set, empty grouping set produce no row. Let's say, if you see the extension, do it. If you understand it, do it.
Yeah, well, I think the like how to represent this, I think probably I'd be inclined towards something that is more like like a list of features. And so because what happens, right, is that it turns out that like there's this weird behavior, and there's another one which is that, like, you know, the ordinal is always negative or something in a grouping set. There's some other grouping set thing which is weird that only Databricks and Snowflake does or whatever. And then there's a system that happens to do both of them.
Right.
And so my inclination would be is us to find constants and say, hey, it's an array of any of these constants. Like here's an enumeration of special compatibility flags,
Right.
or variation in behavior flags. And here's the ones that exist. So if we hit one of these things, we're like, yeah, this is an important system. Let's just express it as a behavioral difference flag. We can kind of capture it that way.
It's also the kind of thing where dialects can step in, where we actually already have things in the dialects, which is like, hey, here's the options that you can set on like readrel, for example, and it's like you can declare which ones you support. So if it's like, okay, Snowflake, we support aggregates, but you have to set grouping to this specific thing. Versus like every other system is like, don't do that. We only support the other one, and that's kind of a way to deal with it potentially.
Okay, sounds good. Yeah.
I do want to dig into this behavior because I've also been looking at group by stuff, because like the derivation of types in the output is inconsistent, I'm finding, in various places. So like given part of it is I'm realizing that a lot of systems don't, the output of the aggregate relation changes if you have grouping sets as well. Or technically speaking, I believe it includes like an extra field that most systems don't look at. And also that it changes the nullabilities in a way that
Right. Yeah.
is weird.
Okay, then I'll prepare some PR on this particular thing.
And examples of what the behavior is would be really useful, because I'm like, what? Every time I think I know something about SQL, I'm like, what the hell is a grouping set? Well, I know what a grouping set is, but like, what the hell is it?
Perhaps if we like, let's say, if you're defining some, say, like feature or compatibility field, perhaps for the grouping set is one candidate that a separate message, grouping set compatibility, and then start to adding like all these like corner cases. It could be, yeah, one thing. It's a very complex, yeah.
Awesome.
Okay. Yeah, that's it from my side. Yeah.
Well, thanks everyone.
Thank you. Bye.